Hey everyone, welcome back. Today, we're diving into something that'll really get those brain gears turning. It's all about the anthropic principle. This idea is kind of like the universe's laws just have to allow for, us to be here observing it.
Right. Because, well, we are.
Exactly. We're looking at a fascinating article all about this, and get this, how it connects to that mind-blowing multiverse theory.
Yeah, the anthropic principle is, it's a simple idea on the surface, but it leads to some seriously huge questions about, like, the nature of the universe and our place in it.
Absolutely. Speaking of huge questions, this article starts off with a really cool story about physicist Fred Hoyle.
Oh, yeah, Hoyle.
He used the anthropic principle to make a really specific prediction about carbon atoms.
Yeah, carbon, the backbone of life as we know it.
Right.
So Hoyle was working on trying to understand how carbon forms inside stars.
Okay.
And he ran into a problem where it seemed like the process was way too improbable for carbon to actually exist in the amounts that it does.
Right.
Yeah, it was like the odds were stacked against it.
Wow.
And then he had this like aha moment. He thought, well, if we exist and we're made of carbon, then the universe simply must have a way to make carbon abundantly.
Oh, I see. So he basically used the fact that we're here as evidence.
Right, exactly. He used our existence to actually predict a specific property of the carbon nucleus.
Wow. What property?
A resonant energy level.
A what?
It's a bit technical, but basically a specific energy level that the carbon nucleus needs to have to make its formation in stars much more likely.
So he basically said, if I'm here, carbon must be easy to make.
Ugh.
That's a pretty bold prediction.
Yeah, super bold. And the amazing thing is, he was right.
He was.
Oh, yeah. His prediction led to experiments that confirmed the existence of this specific energy level in the carbon nucleus.
That's amazing.
It really shows how the anthropic principle, when you use it carefully, can actually lead to testable scientific discoveries.
That's so cool. Like, just thinking about ourselves can actually lead to breakthroughs about the universe.
Yeah, it's a pretty powerful tool when applied correctly.
Definitely. But the article doesn't stop there. It dives into how the anthropic principle has been used to support an even wilder idea, the multiverse.
Oh, the multiverse, right. That's the hypothesis that there are tons of other universes out there, each with its own unique set of physical laws.
Right, like infinite universes, each with their own set of rules.
Exactly, and the anthropic principle comes in by suggesting that out of all those universes,
Okay.
some are bound to have conditions that allow for life, and we just happen to be in one of those lucky universes.
So it's not that the universe was, like, designed for us. It's more like we just won the cosmic lottery.
Yeah, that's a good way to put it. We just happen to end up in the universe that works for us.
But hold on, the article throws a bit of a curveball here. It talks about some new research that challenges this multiverse interpretation.
Oh, right. It brings up the cosmological constant.
The cosmological constant.
It's basically a measure of the energy density of empty space.
The energy of empty space. That sounds kind of out there.
It might sound strange, but it's a really important concept in cosmology. This energy, it affects how the universe expands.
Oh, okay.
Like, imagine the universe as a balloon being inflated. The cosmological constant determines how fast that balloon expands.
I see. And why is the expansion rate so important?
It affects everything, like how galaxies form, whether stars and planets can even come into being.
Wow.
And the research article talks about, well, it suggests that the best value for the cosmological constant, like the value that would make life most abundant,
Okay.
is actually much higher than what we actually observe in our universe.
You're kidding. So our universe isn't even the most ideal for life.
That's what this research is suggesting.
So we didn't win the cosmic lottery. We just ended up with a, like, decent enough universe.
Yeah, like a comfortable middle ground, not the ultimate paradise for life.
Okay, I see. So how does this affect the whole multiverse idea?
Well, it kind of throws a wrench into it. If life could be even more abundant in universes with higher cosmological constants,
Okay.
then the fact that ours is lower kind of makes it seem less special.
Less like a 1 in a trillion chance.
Exactly. It makes you question whether we're truly just lucky to be in a life-permitting universe if there are a bunch out there that are even better suited for it.
So this research is adding to the whole debate about whether the multiverse even exists.
Yeah, it's contributing to a growing skepticism within the scientific community.
Interesting.
It's not that the multiverse is completely ruled out, but it's definitely raising questions about how central it is to our understanding of the universe.
So where does that leave us? If our universe isn't this perfect, fine-tuned cradle for life, what did that say about our place in all of this?
That's a great question, and honestly, one that science is still trying to figure out. What's interesting is that, the multiverse has been this really popular explanation for why our universe seems so just right for us. But this new research suggests maybe we need to shift our thinking a bit. Maybe instead of relying on these countless other universes to explain our own, we need to look deeper within our own universe for the answers.
It's a good reminder that science is always changing.
Absolutely.
You might think we have things figured out, and then, boom, a new discovery comes along and throws everything upside down.
Exactly. It just makes you wonder what other surprises are out there waiting to be discovered.
And how will those discoveries change our understanding of ourselves and our place in the cosmos?
That's the exciting part. There's still so much we don't know, and that's what makes exploring these ideas so fascinating.
Absolutely. Well, on that note, we'll leave you to ponder that.
Mhm.
Thanks for joining us for another deep dive.
Always a pleasure. Until next time.
See you later. Bye.
Bye.